Hello students, welcome to class PM. In today's class, we are going to discuss about the second important periodic property, that is ionization and enthalpy, or you can call it as ionization energy. So let's define what is ionization energy. So ionization energy is that the amount of energy required to remove one electron from neutral gaseous atom. So once again we will define what is the ionization energy. The amount of energy required to remove one electron from the outermost shell of a neutral gaseous atom is called ionization energy. So let's take an example. There is a gaseous atom called A. From this A, to remove one electron, then it will be A will become what? A plus. It lost one electron, so that A becomes A plus and one electron. So to remove this one electron from the A gaseous atom, how much energy we require to remove that electron? That energy is called what? The ionization enthalpy or ionization energy. So this ionization energy can be measured in the units electron volts or kilojoules per mole. By using these are the units you can express the ionization enthalpy. Electron volts also you can use, or kilojoules per mole also you can use. So along with ionization energy, there are secondary, tertiary, quaternary ionization enthalpies also. What is that? See, to remove the one electron from the gaseous atom, it is called primary ionization energy, because you are removing only one electron. That's why it is called ionization enthalpy or primary ionization energy. But if you are removing second electron, because already it became A plus, okay, the amount of energy required to remove the second electron from a uni-positive ion. Uni-positive, uni means 1. So because when you remove the electron, what happened? It became A plus. So now A plus is called what? Uni-positive ion. From uni-positive ion, to remove the electron, how much energy is required? That is called secondary ionization energy. So this is the way we can define the amount of energy is required to remove electron from the uni-positive or dipositive or tripositive ions of the elements in the gaseous state are called secondary, tertiary and quaternary ionization enthalpies respectively. Okay, to remove electron from uni-positive is called secondary ionization energy. To remove electron from dipositive ion is called tertiary ionization energy. To remove an electron from tripositive ion is called quaternary ionization enthalpies. So if you take primary ionization energy, secondary, tertiary, quaternary, which energy is greater? So if you arrange them in that, the quaternary energy is greater, next comes the tertiary, next comes the secondary, next comes the primary. Why? Secondary ionization energy is greater than primary ionization energy. Let's see this example. So sodium is there. From sodium you have removed one electron, so that it became sodium plus. Now the effective nuclear charge on the 11th electron in the sodium, the effective nuclear charge on the 10th electron in the sodium, which one is higher? Because when comparing to the 11th electron, 10th electron is much more closer to the nucleus. So that to remove the 10th electron, you have to give more energy when comparing to the removing the 11th electron. You understood? Once again, see here, in the sodium, you have to remove the 11th electron and the 10th electron. First, which electron should be removed? Always the outermost electron, that is 11th electron. So when comparing the distance from the nucleus to 11th electron, nucleus to 10th electron, the distance between nucleus and 10th electron is smaller than the distance between 11th electron and the nucleus. So that you can easily remove the 11th electron than 10th electron, because 10th electron is most closer to the nucleus. That's why you have to give more energy to remove the 10th electron. That's why the secondary ionization energy is greater than primary ionization energy. Obviously, the same way the tertiary is greater than secondary, the quaternary is greater than tertiary. Okay, this is the way ionization energy you can define. So if you take the example, to remove one electron from the sodium, we need, experimentally it was found that 495 kilojoules per mole energy is required. But to remove the second electron, that is 10th electron from the sodium plus ion, you need 4581 kilojoules per mole energy. See the difference. To remove the 11th electron from the sodium, you need only 495 kilojoules per mole energy. But to remove the 10th electron from sodium plus ion, you need 4581 kilojoules per mole energy. That's why the secondary ionization energy is always greater than primary ionization energy. Now, in the next class, we are going to discuss about what are the factors that affect the ionization energy. So, in the next class, we will discuss the factors which influence the ionization enthalpy.